Dear students, in today's class we discuss F distribution. It is also known as F test for equality of population variance. See the test first. Let x1, x2, x3 up to xn and y1, y2, y3 up to yn be the values of two independent random samples drawn from the normal population with the same variance sigma square. Then the test statics of S test, then test statics for F test is given by F is equal to S1 square by S2 square, where S1 and S2 give the sample variance. You need to ensure, while using the formula, you need to ensure that S1 should be greater than S2. Normally, a F test is used to check whether the two samples are from the same normal population having the same variance or not. Okay, so few notes which we need to remember while doing the problems on F test. The first one, as I told you earlier, normally S1 square and S2 square are taken in such a manner that in F test, the formula for F, the numerator should be greater than the denominator. Second one is the condition under which the hypothesis is accepted or rejected. We compare the F calculated value for a given problem with the standard F value of 5% degree of freedom or 1% degree of freedom. If F calculated value is less than F alpha, then the hypothesis is accepted. Hypothesis is accepted means the two samples are from the same normal population having the variance sigma square. And if F cal is greater than F alpha, then the hypothesis is rejected. It means the two samples are not from the same population with the same variance. Now let's see a problem on this. The problem says two samples of sizes 9 and 8 give the sum of the squares of deviations from their respective mean equal to 160 inches square and 91 inches square respectively. Can these be regarded as drawn from the same normal population? It is given F 5% 8,7 is 3.37. So this is at 5% degree of freedom. So let's see how to solve this problem. First, they have given us the sample size. We denote them by N1 and N2. N1 is 9 here and N2 is 8. F of 5%, 8,7 is also given as 3.73. In the problem, they have given the sum of the squares of deviation from their respective means. That means summation of xi minus x bar square, which is 160. And for the second sample, we are denoting this by yj minus y bar the whole square, which is 91. We have the formula for sample variance, which is S1 square is equal to 1 by N1 summation of xi minus x bar the whole square. Substituting the values, we get S1 square as 17.78, whereas S2 square, we are using the data for the second sample, we get 11.375. Now let's use the formula for F, which is greater variance by smaller variance. By substituting, we get F is equal to 1.56. So comparing it with F of 5%, we see that F calc is less than F 5%. Hence, we can conclude the two samples are drawn from the same population with the same variance. Let's see another problem. It says the measurements on the length of a copper wire were taken into experiments A and B. Given below test, the experiment given below. Test whether B's measurements are more accurate than A's. Reading taken in both the cases being unbiased. Here also f of 5%, 8,7 is 3.73. The A's experiments values are 12.29, 12.25, 11.86, 12.13, 12.44, 12.78, 12.77, 11.90, and 12.47. The observations from B's experiment are 12.39, 12.46, 12.34, 12.22, 11.98, 12.46, 12.23, and 12.06. Okay, so from the given data, first we need to calculate Sx square and Sy square. For this, we first need to calculate the mean x bar. The formula for mean is summation of xi by n1, and we get that as 12.32. Remember, the number of observations in A's experiment is 9, which we are denoting by n1. Substituting or using the formula for Sx square, we get Sx as 0.098. Repeating the same steps for the second experiment, B's experiment, N2, number of observation in B's experiment are 8. The mean is 12.2675. Sy square, we get it as 0.028. Now, we use the formula for F, which will be greater variance by smaller variance. So F, we get it as 3.5. Here, we can see that F calc is less than F 5%. F 5% is 3.73. Hence, there is no reason to say that these measurements are more accurate than A.